Hi, Josh here, and you're watching 610 Garage. Learn it, build it, teach it. In this episode, we continue the SwingLink saga. Today, we'll be making the shaft that the arm of the SwingLink will be mounted to. We will also make the nut that will keep the shaft in its place. The SwingLink, of course, is an arm to reverse the output of my Jeep's steering box. If you don't know what that is, you really should go back and watch the first episode, SwingLink, the plan. This is what we will be making. As you can see, fairly simple. We have an O-ring groove here, 2 bearing seats, and some threads for a nut. As a side note, the rod that I am using is this size. Yeah, I can't turn this part down. This is probably stupid, but hey, rod's expensive. Which makes this step all the more important. We start out by chucking some rod. I need to drill a hole for the live center to support the back. So I use a tool holder that I don't use anymore to apply pressure to the slowly spinning rod. This centers the rod enough for me to drill my tapered hole that the live center will rest in. With the rod steadfast in the lathe, I mark out where the O-ring's groove will be with marking fluid and a caliper. And now I cut the O-ring groove with a cutoff tool. The tool is smaller than the groove. I make one groove, then move the tool over to cut a second groove. I measure this move with the use of a caliper. I then clean up the groove with a file. I then test the fitment of the groove by placing the O-ring. I was apparently so enthused by my success that I left it there. Next, I turn down the shaft to the next largest diameter, which is this first bearing seat. Like the housing, I turn this dimension down to a press fit of FN5. Well, will you look at that? I finally took off that O-ring. Not sure what took me so long. I turn down the shaft in front of the bearing seat. This is so I don't have to press the bearing on all the way down, because that would be annoying and stupid. Then, mean commenter would have to show up. Rats, he's here. Anyway, I then grind down the bearing seat to the tight FN5 tolerances. Knowing that I will need to remove this bearing at least once, I remove some material behind the bearing. This will create a slight gap behind the installed bearing, allowing a bearing splitter to wedge in between the shaft and the bearing. I want to remove the shaft to test fit the bearing, but I have more work to do on this shaft. So with marking fluid, I scrape out the position of the shaft within the chuck. This way, I know that all my work will maintain accuracy. I take out the shaft, press the bearing on, and... Hey moron, you made that shaft too short. Yeah, I think everybody sees that. It had to be said. No, not really. So yeah, the shaft is too short. You see, what happened is when I made the housing, I decided to make the housing longer. But I failed to update my plan, and I followed the plan to make the shaft so the shaft was actually shorter than the housing. I messed up. So, back to square 1.5. I cut a new O-ring groove at the correct position, and turn down the new bearing seat. With that little mistake corrected, I turn down the second bearing seat, which isn't technically a bearing seat. I accidentally ordered 2 of the same size bearings. So this bearing is going to be on a bushing, which I guess would make this a bushing seat. I then turn down and thread the end of the shaft. This is for the nut that will keep everything together. I am cutting these threads to a 7/8 inch by a ridiculous 32 threads per inch. Yeah. 32 TPI is a ridiculously fine thread. but this nut controls how much pressure the bearings are going to be under. I went as fine as an adjustment as possible. Anyway, this completes the shaft. Onto the castle nut.
And let's be honest, you guys know the drill. Face, drill, and bore.
Now, have you ever seen a nut that was round? Yeah, me neither. To the mill!
Hey, don't do that stupid spin transition like you did in the last video. That was stupid.
Yeah, okay, that's fair.
I place the rod into the mill and center it with a coaxial indicator. Yep, still hard to say. I then cut 4 flat sides onto the nut. I would have done 6, but I don't have an indexing head, so we're stuck with 4. I then turn this boring, plain nut into a castle nut. I do this by cutting 4 slots into the nut. This will allow for a cotter pin, which prevents the nut from coming loose.
Internal threading is always a pain. That's why I tend to avoid internal threading on the lathe when the threads are below an inch in diameter, which these are.
So I am using a tap to thread the nut, and I am using my lathe as a really large, heavy clamp. Actually, I am using the tailstock to help align the tap to the center of the hole. Now, this would have gone much faster, but those slots messed up the tapping. The tap would have a tendency of slipping into the slot and losing its place. So the tap and the threads would bind. I eventually got it, but I probably should have tapped it first or bored that section larger so that the tap could slide in past the slots. And a castle nut is born. All that is left is to find this stupid thing. I know it fell down here someplace.
And the shaft is done. Ish. It's done-ish. It's not completely. It's done for this video. The front of the shaft needs to be trimmed down, but I don't know how long to trim it. I need to get the SwingLink onto the axle before I can measure that. In the next episode, we will make the base for the SwingLink housing and weld the two together. So be sure to subscribe so you don't miss it.